Okay, so we're going to look today at angle side angle and angle angle side. Okay, so an included side is the side that lies between two angles. So if I'm talking about some random triangle and I have this angle and this angle, this is the included side. And we have an angle side angle congruence, which tells us if two angles and the included side of one triangle are congruent to two angles and the included side of another, then the triangles are congruent. Okay, so if these are our triangles, and let's say angle B is the same as angle D, angle C is the same as angle F, that would mean BC would have to be the same as DF in order for those triangles to be congruent. So and now you'll notice when I listed this, I didn't do DEF, I did EDF because angle B is congruent to angle D and C is congruent to angle F, which means that A and E would have to match. Alright, so I'm going to prove these two triangles are congruent using angle side angle. So I have statements and reasons, and I start always with the given. So QS bisects angle PQR, and then I have angle PSQ is congruent to angle RSQ. So I'm going to label these. You're welcome. So I'm going to label these QS bisects PQR. Well, bisecting, and it bisects angle PQR, that means this angle 1 and this angle 2 are going to be the same, because bisect means to cut in half. So I'm going to write that in there. Angle 1 is congruent to angle 2, and that's the definition of bisect. Okay. So I'll label those. Angle 1 and angle 2 are the same. And then angle PSQ, so PSQ, that's this angle right here, is the same as angle RSQ, that's this angle right here. Those two are the same. That was given. Now I'm looking for angle side angle. So I have two angles. I need the side in between to be the same. Well, it's the same side, right? So that means it's the same automatically. But we have to say so. So anytime we say something is itself, it's the reflexive property. So now I had the bisecting gave me these two angles. They already gave me these two angles. This side is itself, so now I have angle side angle. Okay, ZX bisects angle WZY. And I'm just going to make this easier, I'm going to label these angles. WZY is this angle here, because it goes W to Z to Y. And that was given. And then XZ bisects angle YXW, also given. And I'm going to label that one green, just so we've got YXW, so that's this angle. Now bisecting means it cuts in half. So if I come in here and I label these angle 1 and 2 and 3 and 4. That way I don't have to name them like with letters. I can just call them 1, 2, 3, and 4. Because this yellow angle is bisected, angle 1 is congruent to angle 2. Because that's what bisect means. We cut it in half, so that means these two halves are equal, even though in the picture they're not, because, well, it's me drawing a picture, I'm not perfect, right? But we're saying that they are, because that's what bisect means. And then we have angle 3 and 4, because the green angle was bisected. Okay, so now I have that this angle and this angle are the same. This angle and this angle are the same. And I'm looking for angle, side, angle, so I just need the side between those angles to be the same. And looky there. It's the exact same line, it's itself. So we throw that in there. And you can call it ZX or XZ, it doesn't matter, because it's itself. So that's reflexive. And so then I get that last line. By angle, side, angle. Angle, angle, side. Okay, and so it says if two angles an adjacent side of one triangle are congruent to two angles and an adjacent side of another triangle, then the two triangles are congruent. So if I have, let's say, angle B is congruent to angle D, and C is congruent to F, okay, I need an adjacent side. So I can go angle, angle, side like this. Or if I'm, say, I is to L and J is to M, it can be angle, angle, and this side. So it can actually be side, angle, angle, or angle, angle, side. It just depends on what direction you go around the triangle. We just call it angle, angle, side. So this way I'd go angle, angle, side. Here I'd go angle, angle, side. So it doesn't matter which side the side is on, just so long as it's touching one of the two angles. Does that make sense? So in this case, we're touching angle F and angle C. Here we're touching I and L and not J and M. So we just touch one of the pairs of angles that match. Moving these things congruent, I'm going to do my two-column proof again. And so I'm going to have some statements, and I'm going to have some reasons. I've got DAC is congruent to BEC. Okay, so DAC is DAC, so that's this angle here. And BEC is BEC, so that angle there. So these two angles are congruent. That was given. And I've got BC is congruent to, sorry, DC, not BC. Although I guess it doesn't matter. Also given. So BC BC is this length right here is congruent to this length right here. That is a jive. This should be AC and EC. Yeah. Sorry about that. That was my typo. So this whole length here is the same as this whole length here. And we're looking for the triangles that we're trying to prove are congruent is we're doing this triangle here and this triangle here. Okay. We can get to angle side on this proof. Okay. What I'll use to do that, it'll make it a longer proof, is that angle C is the same in both triangles. And then I can add up to 180, and then I can subtract to get that angle B here, angle 1 maybe, and angle 2 are congruent. However, if I was just given this picture and I wasn't told this, I was just told to prove this, that is not the way I would go. That's the harder way to go. So what I'm going to do is I'm going to take that out. And I'm going to prove this the way I would prove it if I was just given this triangle. So I was told these were the same. And then this whole length here is the same as this whole length here. Correct? Well, angle C is shared by both triangles. And it is congruent to itself. And then I have angle, side, angle. That is the easier way to prove these two triangles are congruent. Can you do angle, side? Sure. It's going to add about 4 more steps. So I wouldn't do that. It's just silly. So then I'm going to go to the triangle ACD is congruent to triangle ECB, angle, side, angle. When you're, okay, like in this example where it said to use angle, side, if you see an easier way, like maybe it starts out and you're looking at it and you go, oh, I need to use side angle side on this, but then you look at it and go, wait, that's a right triangle. I can use hypotenuse leg. Then just do that. You know, take the easier route. The proofs in math, when mathematicians first started proving things, the proofs were kind of probably longer than they needed to be, but over time they made them more elegant, simpler. Try to get there in the least number of steps, most efficient, because that's what math is about, is efficiency. It's trying to get to the problems, solving the problems in the easiest possible way. Okay, Pythagorean theorem, there's something like 67 different proofs for the Pythagorean theorem, because people have been trying to make it a more elegant, simpler, shorter proof. So, okay, this is going to bring us back to our parallel line theorems. Okay, so for anybody that doesn't remember, these tell me the lines are parallel. Those arrows. So these two lines are parallel. And I was not given any statements that weren't given. If you look on your worksheet, this is like the picture at the top of page 52. Somehow I deleted it. So you'd be given that U is the midpoint, since I labeled it wrong, of RT. And that RQ is parallel to ST. So those would be given. Okay. Now, U is the midpoint of RT. That's the midpoint right here. That means this side is the same length as that side. So RU is congruent to UT because that's the definition of midpoint. Now I have parallel lines with transversals. So if you remember with our parallel lines with transversals, this angle is the same as that angle. This angle is the same as this angle. And those are alternate interior. So that tells me that this angle here, I'm going to call it angle 1, is congruent to this angle here too, because they're alternate interior angles. And then let's do green. This angle here is the same as this angle here because they're also alternate interior angles. So I have angle, angle, side, angle, angle, side. Okay, so we have our summary, which is side, side, side. So we're going to have this side, and this side. And then we have side angle side. Okay, so you have one side, and then another side, and then the angle between them. And then you have angle, side, angle. So we have an angle, another angle, and the side between them. And then you have angle, angle, side. Where we have one angle and another angle and the side next to them.